Welcome back to Urevise, where we talk about everything exams. Let's take a look at question 8 from the 2016 exam. According to the examiner, this question was actually 80% of candidates got this question right, which is really excellent. It's talking about it's thermodynamics, looking at energy profile diagrams of processes or reactions, and this is a concept that we learn from in our curriculum from year 10 through to year 12. Now, most students will be familiar with this, and it's just looking at the graph and figuring out which one is endothermic, which one is exothermic, and looking at relating this to reverse activation energy and forward activation energy, etc., and putting that information together to answer the question. Let's read the question. It says, which of the following energy profile diagram best represents a spontaneous exothermic reaction? Generally, spontaneous reactions or processes have very low activation energy, forward activation energy. I missed the word forward here. They have very low forward activation energy, right? And an exothermic reaction, reactants must have a lot more energy than products. R represents reactions, so I've got my reactants and products here. Reactants, products should be an R. These I've got my products and reactants here. Now, looking at this here, we're saying all reactions in which the reactants have got more energy than products, that means this is an exothermic. So this qualifies as an exothermic. If we look at this here, this is actually endothermic, and this one here is exo. So this one is out. We are looking for an exothermic, not endothermic. This leaves us with, once we eliminate this, we've got a 1 in 3 chance of getting the right answer. Let's see if we eliminate this one as well, because it's endothermic. Products have got more energy than reactants. We've eliminated 2. Now we've got a 50-50 chance. Now we need to consider these two. Which one is the most correct answer? Now, we have to consider the amount of forward activation energy. This one here, according to this diagram, requires a lot more forward activation energy than this one, which means you don't need an awful lot of energy to get all your reactants into an activated complex that's here. You just need a tiny amount, which means this one will be highly spontaneous because you don't need an awful lot of energy to kickstart this. And also, if you look at the delta H for this one, the change in enthalpy is so high, which means most of this energy can also be used by the system to continue or propagate the reaction, which is another good thing. So at the end of the day, the most important thing here is once you get to a situation like this, where you've got 2 exothermic reactions, you want to consider which one is highly likely going to be spontaneous. The one with low forward activation energy is going to be your reaction, your spontaneous reaction. Okay. Another thing I want to mention as well, just because as usual we try to kill many birds with one stone. What else could you do when you're preparing for your exam around this? You should be able to draw these energy profile diagrams given information, which means labeling, drawing and fully labeling this graph from where the activated complex is, which one is activation energy, the delta H, which is the change in enthalpy, label your activated complex, etc. So you should be able to do that. One thing I've seen in some exams, it's not about sketching the graph. They might ask you to sketch the graph. They will give you values to use to think around, so that when you sketch your graph, it has got some sort of scale. Okay, it's not really like drawing, it's still sketching, I would say, because they'll give you like rough values that they'll give you, maybe the delta H, the activation energy, and you have to draw the graph using those numbers to reflect the sort of numbers they are giving you in your graph. Your sketch must reflect that. So those are some of the things you should be able to do. Now, I've come to the end of this question. I'm gonna love you and leave you, and I shall see you when you attempt the next question.
Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.